Let me introduce you to the diode. In this video, you're going to immerse yourself deeper into the diode, what it is, how it's connected, and its use in real life. This is the real diode. That's the real diode. I will zoom so that you see how it really looks like. I want you to note that it has a dark band at the far edge, one side. At one side, it has a dark band, only one band. It doesn't have several bands like the resistors. It only has one at the far end. And that's not a mistake. You're going to learn why a diode has a band at the end. So let me just draw the physical diode, how it looks physically. So physically, it just looks something like this. This cylinder, then this cylinder at the end, we have a band like that. We have a black band at the end. It goes that way. So what is this band at the end? This band at the end is the negative side of the diode. So anywhere you see the band, that will always be the negative side of the diode, and this other side therefore will automatically become the positive side of the diode. So we've talked about it severally, and we've mentioned that in electronics we have standard symbols that are being used universally for people to be able to know diagrams anywhere. So we have a standard symbol. This is the drawing. This is the drawing. And the standard symbol for the diode looks like this. So the standard symbol, the positive side looks like this, and the negative side has a band. Its band just looks like that. So just like this and just like this. So where you see a band, that's the negative side of the symbol, and where you see this other triangle side, that's the positive side. So we have the negative side and we have the positive side, and this is the universal symbol of a diode. Let me make sure that we have the name written here so that we know that we're talking about a diode. Now that you've known what a diode is, you've seen a drawing of it, and you now know a symbol of a diode, how it's represented in a circuit, of course using a symbol. We want to go to the next part of a diode, and it's just us understanding the applications of a diode. Why do we need diodes in real life, and how do we use diodes in whatever things that we do? So that will bring us to a discussion on the motors. Think of the motors and the places where you normally see a lot of coils or wire windings, places which can generate power. So we normally use diodes in places where, when the circuit is put off, there is this small current which will still be generated by the circuit, and if it goes back to the circuit, it will end up blowing up things or messing up or bringing up abnormalities on our circuit. Some of the things having a lot of windings which mostly might generate power are relays. Relays are like switches. We also have motors. If you open a motor while at home or something, you have those small cars which have things which are inside that roll those wheels. That motor, if you open it inside, you'll find a lot of coils of wires. Trust me, if you take that and you start rotating it round and round and round, it will now change from being a motor to becoming a generator, and it will now give out small amounts of current, which will result to power. So we always avoid that by using diodes, so that we create a small loop where that small power generated will rotate, will cycle in, instead of getting back to our main circuit and destroying it. I'm going to show you, we're going to come up with a circuit, and this circuit, of course, is connected to a motor of ours. Let's assume that our circuit is getting power from 5 volts, and we are also going to give our circuit a switch. So we have our power source here, and our power source is 5 volts, and I am adding a new term, DC. I know you've heard about DC, or you've seen somewhere in our appliances or your chargers. You've seen DC. What DC means? DC means direct current. The power that comes raw from the wire lines, the one that is being transmitted, it's always AC. The one that goes to your bulbs, that's normally AC. But now, when you plug your socket, that adapter or that charger of yours normally converts that AC in full. AC in full means automatic, or alternating, not automatic. Alternating current. It normally converts that alternating current to direct current. Alternating current is the normal electricity on the power lines, the one which just comes directly to your house. And when you want your devices to use it, you need that charger, you need that adapter to convert it to normal DC. The power that comes directly, voltage that comes directly from your battery, is normally DC. But the one from the wire lines is the alternating current. Alternating current. But for now, we are going to use direct current, DC. This is the one that we are using. Okay. The positive side for this circuit, we are going to use, we'll have to give it a switch. We'll give it a switch. So that's going to be a switch. It can be a push button or something. Now it will go direct. We are going to draw our motor here. This is our motor. Just call it M so that we know it's our motor. So our power will go inside the motor. And from the motor, of course, this will be the positive side, because this is positive 5 volts. This is the positive side. This is the negative side. So the negative side, as we have always been saying, it's going to the ground, G and D. Yeah. Now, when this one is closed, of course, current will flow towards this direction. It will flow towards that direction. So this is the current. This is the switch. That's how you draw switches. That's the current and that's the switch. So I know right now you are conversant with circuits, and we've just drawn a typical circuit having one motor there. That motor is being run by 5 volts. We put a switch, and right now the switch is open, but when you press the switch and you close the circuit, current will now flow through the motor and the motor will run. The problem with this circuit of ours, when we open the circuit like this, when the motor was still running, the motor won't hold brakes at the same time. It will continue slowing down. While it's slowing down, the motor has now changed from being a motor, it's now a generator, because it's giving out some small power because of those windings and magnetism. That's how power is being generated from the power station. There's normally a motor there, and that motor, that motor is normally rotated with water, and by being moved around with water, the turbine, we normally call it a turbine. when the turbine is moved around with water round and round and round, it normally generates power. So in this case, when we stop the circuit and the motor is still rotating, it now changes, it becomes something like a turbine. And while it rotates, while holding its brake, trying to stop, it gives out that small power. That small power is bad. It's not supposed to go back to the circuit, because when it goes back to the circuit, it might find things in the circuit and blow them apart or something and bring some abnormalities on your circuit. So you have to introduce what we've been talking about, the diode. So how will you introduce the diode? You will introduce the diode by connecting the diode in a reverse order, meaning the diode will be connected from the sides of your motor, and by being connected on the sides of your motor, the negative side of your diode, that is the side having the bar, will be connected to the positive side of your motor. That is what I mean by the reverse connections. This is the negative side. We said where there is a bar is the negative side. The negative side will be connected to the positive side, and the positive side will be connected to the negative side. Note that difference. The diode connected to a motor is connected in a reverse direction. So for the diode, this is the negative, and this side is the positive. That's how it should be connected. So when the switch is open like now, of course we are assuming that it was running previously very fast, it will take time to hold brakes. That small power or current, it's normally called reverse current. The reverse current that will be given out, instead of that reverse current going this side and destroying our circuit, this green side, the reverse current will now flow in this direction. It will flow in this direction, and it will keep rotating. It will flow, it will just rotate in this cycle. It will just go round and round and round. So when you are, let's name it, it's the reverse current. So your reverse current will go through this cycle, and it will keep going round up to when your motor will stop. And by doing that, you have saved your motor and you've also saved your circuit. So a good practice is always having a diode attached. Always have a diode attached to anything having a lot of windings. And this can be, it can be one, a motor, or it can be two, a relay. They have a lot of windings, and when you stop them, the energy keeps moving, and when the energy moves again and again and again, the current, it's normally called the reverse current, when it moves to the normal circuit, it will end up spoiling things. So that's all about the diode. See you in the next video.